What's up? What's up? It is Thursday, April 11th. Now, here's the crazy thing. I will not be back inside this classroom to teach y'all until Thursday, April 18th. So a whole week. But you got me here, okay? Live and direct. Make sure y'all stay locked in. Do what you're supposed to do. Tomorrow we having a quiz. I got study stuff for the quiz. Don't trip. It should be all stuff you should know from the last two chapters. It shouldn't be this big old deal. Now, if your sub is then you got to still be good and locked in. If your sub is whoop, then you still got to be good and locked in. Make sure to bring headphones. You're going to need a charger. You're going to need your Chromebooks. So make sure you handle all of that business, okay? Obviously, you're going to need your notebook and you're going to need your journals. You're going to need all the things, right? Everyone say all the things, right? All the things. So that's what you're going to need. Okay, cool. We're just going to go over some things. We're just going to review a little bit from yesterday. I'm going to tell you in tomorrow's video, I'm going to pick a page from 48, 49, or 50, and you're going to have all of that wrapped up and done. So again, just pick from don't worry, I'm going to pick from one of those pages. It'll be in tomorrow's lesson video, so don't trip out, okay? So don't trip out. Make sure that you watch the lesson video in its entirety in order to get to know what page it is. Okay, so we talked about this yesterday. We talked about the patterns of the earth, the sun, and the moon, and this idea that the earth goes around the sun, and not only that, but it rotates as well, and that the sun is kind of staying in the middle, and it's kind of just rotating around in that spot, and then the moon is rotating around the earth, but it's also going around the sun as the earth is going around the sun. So we talked about those things. Put that in written descriptions, and we drew some models. Make sure your models actually have pictures on them. Again, we talked about that yesterday. You can go watch yesterday's video if you want a detailed version of that. Okay, cool. Now, let's just talk about this for a second, and this kind of models that out, right? Kind of what we were talking about yesterday. Hey, see how the moon is going around the earth? Also, I do want to point this out from this video, is this idea, is that if we really wanted it to be accurate, we'd probably be one of these little tiny dots right there. That would be the Earth, because there is approximately, you could fit 1.3 million Earths inside of the sun there, okay? So that, again, you can fit about 1.3 million Earths inside of the sun there, okay? Now, the reason we have it much bigger is for learning purposes, because if it was really that tiny, it would be hard to see what's going on. So that's why it's not scaled appropriately, okay? So sometimes that happens. All right. Now, also, just an FYI, the sun is a pretty mid-tier sun. Our sun is not huge. It's our sun. We love our sun. But it's not huge as it pertains to stars, but it is an awesome star nonetheless, and it is the closest star to us. Now, we talked about this yesterday, and again, go back to yesterday's video if you want a detailed answer, because I'm not giving those out today. So we talked about this yesterday, and you should go ahead and check that out right there. But what patterns are caused by the Earth, the sun, and the moon systems? And we talked about various things like seasons. We talked about day and night. That's another pattern that we see each day. We also talked about the year. We also talked about, what's the other thing? Oh, we talked about the tides, right? And that is about, you guys remember? About the moon's gravitational pull on the earth as well. Since the moon is massive, it does still have some effect on us as well, because gravity, the moon also has its own gravity. Okay, cool. And again, if you want more details, go back to yesterday's video. All right, on to this next thing. Now, we talked about this, and in yesterday's video, if you did not watch it, I showed this in pretty good detail of being able to show how the Earth's shadow gets casted onto the moon. So the moon always stays the same size, but what's happening is what's visible to us is changing, right? So that is what's changing, what is visible to us. And as the Earth is in between the sun and the moon, then the Earth's shadow gets casted onto the moon. And again, if you want to see a pretty good video of that, I had one yesterday, and it actually came out pretty good. I was actually a lightweight impressed with myself. Lightweight impressed. Okay, cool. Now let's talk about this, and we've got to switch position. All right, what's up, y'all? Imagine I am the Earth, right? And the sun obviously is over there. So right into the sun. Yeah, nice and bright, right? The sun's nice and bright. So as the Earth is rotating, right, and it's becoming darker as I'm like getting away, I can start to see some constellations, right? I can start to see some constellations. So I'm turning around, and now I know it's a little bit light over here, but you can see now it's a lot darker. It's much easier to see Virgo when it's dark. And then as we keep turning around, okay, we can see Leo over there, right? But as it starts to become brighter, it's going to be harder and harder to see some of these constellations. Because it's more like this, right? Like I cannot see any of those constellations over there because one, they're far away from us. They're really far from where we're at. But then also, the other thing is the sun is so bright that its light drowns out being able to see the other constellations. Answer some questions using this piece of information. All right, now we're back. I do just want to make this clarification, and just remember that as the Earth is rotating, but it's also moving counterclockwise around the sun. So at certain times of the year, we are closer to certain constellations than at other times of the year we are much further away from those constellations. Okay, so just so you guys can see that as well. So then obviously the ones that we're closer to, they're easier to be visible at night when we're not facing that bright light of the sun. Okay, so I just want to put that out there. Also, I wanted to say this: there's two different things here. There's astronomy, astrology. So astronomy says here are these stars, and we've actually given them, like, they actually have scientific names. So we have that, right? So here are these stars, right? And this is where they are located. Astrology says here are these stars. Same thing astronomy says, but then it says these stars look like a crab, right? They look like a crab. So there must be some sort of story or something associated to the stars and their constellation, and we'll call that Cancer. Now, if you look at this next one, astronomy says here's these stars, and they're kind of together, and they kind of look like this. This is where they're at. This is where they're located. These are their names. These are the size of the different stars. Astrology says these look like two people in the sky. We're going to call them Gemini, and they're going to be the twins. That's what we're going to call them. And then it has a story associated with how did they get into the sky. So, again, that's how astrology works. Again, it's people ascribing meaning to the stars, the moons, the planets, and their movements, where astronomy is more trying to understand where are the stars, where are the planets, how do they move, how do they work, how do these things interact, how big are they, what are they made out of. That's what astronomy is. It's just studying them themselves. Okay, so I just wanted to make that clarification. Also, let's go ahead and answer these conclusion questions. So on the bottom of page number 48, you should have half that page already. I think it's way over there. I don't think I can zoom in on it, but you should, on the top part, you should have the answers to the phases of the moon. And on the bottom part, you're going to put the answers on this. And you're going to put conclusion questions, and you're going to put number 1. So what did you observe as you rotate? And most people put that they observed day and night, because that was one of the most obvious things as we were rotating in that video, right? It was real obvious when the bright light of the sun was shining, and it was like different when it was not. Okay, what does the constellations appear to do as we rotate? And a lot of people said they appear to disappear, which sounds weird in a sentence, but they appear to disappear. And so that's the thing. When the light of the sun is shining, it's hard to see them. Also, when we're not close to them, it's hard to see them. What do you observe as you revolve or orbit around the sun? You become further or closer to different constellations. So we're moving, becoming closer or further away from different sets of stars, and those sets of stars, we call them constellations. Do the stars stay in one spot, or do they move? Now, the stars do move, but they relatively stay in the spot that they're in. So like our sun is spinning around, but it relatively stays in the same spot. Now, there is a deeper explanation to that. We're not going to get into that today. Okay, so hopefully you've got those questions answered on the bottom of page number 48. So remember, I'm going to choose page 48, 49, or 50. One of those 3 pages you're going to turn in tomorrow. You have to scan and turn in. Okay, cool. Last thing is this. We will be having a quiz. So there's a kinetic and potential energy study guide. Those are slides. There also is a quizzes for kinetic and potential energy in there as well. They should totally look like, hold on, let me see. Do I have it right here? I think I have it right here. Boom. So one of them is going to look like this, and it is the study guide. And then I'm going to go and just click the quizzes. So we're going to go to the study guide first. We're going to say authorize, boom. So it has these definitions in there, okay? And one is for energy, systems, kinetic energy, potential energy. These are all things you should already know. Could you answer some questions about kinetic and potential energy with that? These are all things we went over. Also, what are the different types of potential energy that we covered in the class? We talked about some of them, but 3 of them we did labs, and you're going to have to answer a question as it pertains to one of them, okay? Also, potential and kinetic energy, can you tell us what each of these letters stand for? Can you also tell us what is the units, right, that are associated with each letter? Can you also calculate using kinetic energy or potential energy? Can you calculate kinetic or potential energy? Also, can you calculate speed? Can you tell us that velocity is equal to speed and speed is equal to distance divided by time? Could you calculate speed if we needed you to do that? Okay, cool. So again, can you calculate kinetic energy? Can you calculate potential energy? These 2 worksheets, we worked on that kind of extensively. Also, you're going to need to answer this question as it pertains to the type of potential energies that we covered in the class. So again, that linking literacy, most of this stuff is in your notebook and in your journal. Nothing should be crazy. And then there is this quizzes right here to help you study. If it was me, I would walk through both. I would do a couple practice problems as well. I would just figure out problems and calculate them. I would go back and be like, oh, do I know how to do that? I would just practice that. All right, y'all. Love y'all. I won't see y'all in the class until Thursday, but I will be right here online for you. And I will see you on the next one. Peace.